Hello all, this is AK. Welcome to AK APT Logics. In this channel, we are going to discuss about aptitude and reasoning. In this series, we are going to start with the first chapter in aptitude, that is number systems. Today, we are going to discuss about the part 1 video of number systems, which is known as concept of number systems. In this part includes numbers, face and place value, types of numbers and some of the facts related to numbers. Let us begin this video. Let's dive into this video. Yeah, we are going to discuss fundamental concepts. In this first, we are going to discuss about numbers. Okay, yeah, let me change my marker. Yeah, in Hindu Arabic system, we have 10 digits, 10 distinct digits, 10 different digits, namely 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 4, 5 up to 9. Okay, a number is denoted by group of digits called numerals. See, digit means the single digit which is distinct. Those are from 0 to 9. What is meant by numeral means group of those digits means when we going to mix those digits it will become a big number, right? So group of those digits will be called as a numeral. For example, if we are going to take this is the example. This is a big number which is the combination of all those digits, 10 digits which are from 0 to 9. Okay, which is called this is called as numeral. Okay, this is called as numeral, which is spelled as 56 crores 13 lakhs 7,090. This is all this is spelled as 56 crores 13 lakhs 7,090, right? So this is how is it? It is means based on the place values. For zero, the place value will be for zero. If you are going to take place value, uh, for zero place value will be 1. For 9 place value will be 10. Okay, 10. For 0 again 0 there is another 0, right? For this place value will be 1000. Okay, and so on. For this 5 place value will be 10 crores. Okay, so based on those place values, we are going to spell that big number which is made up of group of digits. Okay, next coming to second topic, we are going to discuss about face value and place value of a digit in a numeral. Face value and place value are two different types of values related to a number. Okay, and place value are only single digit values, means no, face value is a single digit value, place value may be a single digit, no, or it may be a group of digits. Okay, so place value is also called as local value. So let us discuss about this topic. The face value of a digit, sorry, let me the face value of digit. Okay, the face value of a digit in a numeral is its own value at whatever it place may be. For example, if you are going to see in the above example, the face value of 5 will be 5, 6 will be 6, and 1 will be 1, 3 will be 3, 0 will be 0, 7. For 7, it will be 7 only. Let us see some other example for understanding face value in detail. Okay, In the numeral 5789, the face value of 9 is 9. The face value of 9 is 9. Okay. The face value of 8 is 8 only. Okay. The face value of 7 is 7 only. It means itself only. A digit has its face value itself only. Okay. For 5, it's 5 only. Okay. I hope you all got about what is meant by face value. Face value is nothing but it's a single digit. Okay. Whatever number, if we are going to have any large number, uh, in a particular digit, what if we have a question like what is the face value of 9 in a particular 5789 number, we have to say that face value of 9 is 9. What is the face value of 5 means, we have to say that face value of 5 is 5. That's it. Now let us discuss about place value, or the it also called as local value. Okay. Yeah. In the given numeral, for example, in the given numeral, any numeral, if the digit is in a place value of one's digit will be one's digit into 1. It means previously if you are going to see the place value, the face value of 9 is 9, right? If you want the place value of 9, then it will become, it's in one's digit, right? Then it will become 9 into 1, that is equal to 9. Okay. This is this is place value. Okay. For example, if we are going to ask the face value of 8, the face value of 8 is 8. Okay. 8 itself only. If they are going to ask the place value of 8, then it will be in what place it will, the 8 is present in tens place, right? So we have to multiply 8 with 10. 8 into 10, because 8 is present in tens place, right? So 8 into 10 becomes 8 into 10 becomes 80. So the place value of 8 will be in the number 5789 becomes 80, and the face value of uh, 8 will be 8. Okay. For suppose I'm going to ask you guys, take a moment and tell what is the place and face value of 5. So I'm going to give you 5 seconds of time. Just think and tell it. So if you are going to say that the face value of 5 is 5 itself only, as we are seeing here, right? The place value of 5 is 5 itself only. The place value of 5, or the local value of 5, will become 5 into, in what place the 5 is present, in thousands place, right? 5 into 1000. 5 into 1000 will become 5000. Okay. So the place value of 5 will be 5000 in the number 5789. Okay. So the face value of 5 will become 5. So that's only given in the next slide. The place value of one's digit will be one's digit into 1, because it is present in one's place, right? So we are going to multiply that particular digit with 1. Similarly, the place value of 10 tens digit will be tens digit. The value, the digit that is present in the tens place into 10, because it is present in tens place, right? So similar, the place value of hundreds digit will be, the place value of 100 digit will be hundreds digit and into 100. The digit that is present in the place of hundreds and is multiplied with 100, because it's in the hundreds place, right? So I hope you got about the place values and the face value of a given particular number or the number. Okay. For example, in the number 70984, we have place value has place value of 4 is 4 into 1 because 4 is present in one's place, right? So we are going to multiply 1 with 4. Okay, so we get the resultant as 4. So we can say that place value of 4 will become 4. Okay, next place value of 8 will become 8 into 10. How? Because 8 is present in tens place, right? This is tens place, right? See, this is tens place, right? So 8 is being multiplied with 10, so we get the resultant as 80. Next, place value of 9. Place value of 9 becomes 9 into 100 because 9 is being present in hundreds place. 9 is being present in hundreds place, so the place value of 9 will be 9 into 100, 900. Okay, next, similarly, place value of 7 will become 7 into 10,000, 70,000. Okay, so this is all about the place and face values. So let us go to the next topic, which is so there is a note point, right? Note point is nothing but the place value of 0 in giving the place value 0 in a given numeral is 0 at whatever place it may be. Face value and place value of 0 at any position in a given number, point to be noted, at any position in a given number is always 0. This is why, because I'm gonna explain you. For example, here we have 0, right? See, here we have 0, right? In which position it is been there? Ones, tens, hundreds, thousands, right? So if you are going to calculate the place value of 0, 0 into 0 into 1000 becomes 0. Why? Because 0 into 1000 becomes 0. Why? Because anything is multiplied by 0 is always resulted to 0 itself. Okay. So now tell me the place value of 0 is 0 into 1000 is 0, right? What is the face value? Face value is 0 itself, right? The face value of a number, the face value of a digit in a number is always the number itself, is always the digit itself. Okay, so don't get confused. It's very basic topic. The place value, the face value of a digit in a number is always the digit itself. It means the face value of 0 in the 70,984 is always 0. Okay, that is we already know, we have seen in previous slide. So now coming to the place value of 0 is 0 into 1000 because 0 is present in 1000 place. So whenever the 0 is multiplied with any number like 1000 or 10,000 or 1 or 2 or 3 4, any number, the resultant it will be always 0. So it means from this we can say that place value and face value and place value of 0 is always 0. Okay, this is the point that note. You should note this point. It is very important. It will be very useful when you are going to solve no uh, bits related to this concept. Let us go to next topic. Okay, yeah. The next topic is various types of numbers. We have so many different types of numbers like natural number, whole number, integers, and those all. Let us discuss each one of them one by one. Okay, natural number. Natural number is nothing but counting numbers. Counting numbers are called natural numbers. Okay, those are one, starting from 1 and so on up to infinity. All are natural numbers. Next, whole numbers. Whole numbers are all counting numbers, which are nothing but the natural numbers. All natural numbers together with zero, forms the set of whole numbers. See, these are all natural numbers, right? Natural numbers including with zero. Natural numbers including with zero becomes whole numbers, and whole numbers is start from zero. Natural numbers start from one. and so on. Both the numbers are extend up to infinity. Okay, integers. All counting numbers, it means all natural numbers, zero, and negative numbers of counting numbers. It means negative of natural numbers means -1, -2, minus -2, minus -3, like that. Negative of counting numbers means negative of natural numbers, which means -1, -2, -3, -4, and so on. Forms the set of integers. Okay, those are C. Integers start from -infinity to and so on extend up to positive infinity. It means we can't say that what is the first if the question came for you like that, what is the first uh, integer value? You can't say it. If you are going to ask the what is the first natural number, we can say that it has one. Okay, if you are going to ask, if anyone are going to ask you what is the first whole number, you can say that it has zero. It has one. Natural number for natural number, you can say it has one. In the integer case also, you can say that those are starting from -infinity to and ending at a plus infinity. Okay, but we can't able to say that particular value, right? If I'm not going to ask you what is the last natural number, if you can say that it can extend up to infinity, but you can't able to say that value, right? So we can't able to say that value, but we can say that those are extending up to infinity. Note that infinity is not a value. Infinity is not a value. So whenever if anyone asking you, the question is like that, what is the last natural number? If you say infinity, it will be wrong. Okay, it will be wrong. You have to say that I don't know, because those numbers are extending up to infinity. So your reply should be like that. Similarly, what is the if someone asks you what is the first integer value, you shouldn't say that minus infinity. You have to say that those numbers are starting from uh, so many numbers will be there, so that we can't able to say that a particular value, but the number will be extended up to infinity. You have to say that like that. Okay, so remember the point, infinity is not a number. Okay, infinity means why you are going to represent infinity means because those numbers we can't able, those are not countable, those are uncountable numbers, so we are going to represent infinity for that cases. Okay, next. Next type of numbers. So set of positive numbers means natural numbers. Okay, set of positive integers means natural numbers, and set of negative numbers means minus of n. Minus of n means -1, -2, -3, -4, and so on. Set of all non-negative integers. All non-negative integers is 0, 1, 2, 3, 4, 5, 6. Okay, so we can't able to say that 0 as a positive number. Okay, or negative number. It's a non-negative number. Okay, 0 also related to positive number only. Okay, yeah. Next, even numbers. A counting number which is divisible by 2 is called even number. Okay, any number which is divisible by 2 which is called as even number. Those are 0, 2, 4, 6, 8, 10, 12, etc. You may get a doubt that 0 divided by 2, how is it possible like that, right? Yeah, see, if you are going to see that 2 divided by 0, 2 0 times will be 0, right? Yeah, then answer will be 0. So if you have any doubt, you can cross out like that. Okay, next, odd numbers. Counting number uh, not divisible by 2 is called an odd number. 1, 3, 5, 7, 9, 10, 9, 11, 13, or etc. All are odd numbers. Odd numbers and even numbers are also extending up to infinity. Okay, So if you are going to take example 5, uh, 2 divide 5 divided by 2, okay. If you're going to take that 5 twos, okay, 5 twos how much? 4, okay. The remainder will be 1, okay. We may have a doubt that we can put the point and we can put the 0, 5, 2 fives can, it will be divisible by 2, no sir. Why you are saying that it's not a even number like that? So what is meant by odd number means even number means the number, it must be completely be a number should be completely divisible by 2 without having any decimal values in its quotient, okay. So if you are going to say that if you are going to divisible 5 with 2, we have getting the answer as 2.5, okay. We are getting the answer as 2.5. It means 0.5 is a decimal value, right? So it's not completely divisible. Okay. So we shouldn't consider like that. We should consider only whole number which is not having any decimal point. Okay. So next, let us discuss about next numbers. Yeah. Prime number. A counting number is called a prime number if it has exactly two factors. Counting number means natural number. You should write like this. Natural number is called prime number when if it has two exactly two factors, namely one and itself. Factors is nothing but if you are going to take a number, for example, 6. 6 can be able to divide it by 2. Uh, 6 can we can divide 6 by 1, 2, uh, 3, and 6. Now 1, 2, 3, 6 are becomes factors of 6, okay. Factors of 6, 6 will become multiple of this 1, 2, 3, and 6, okay. Factors is nothing but if a number, uh, if you are going to have two numbers p and q, if p by q, if p q divides p, then if the remainder is 0, if the remainder is 0, okay, if the remainder is 0, then we can say that q is a factor of p, and p is a multiple of q, okay. Q is the factor of p, and p is a multiple of q, okay. Okay, all prime numbers less than 100. Let's see, 2, 3, 5, 7, 11, 13, and so 90, 97, right? So all these numbers are having factors only two numbers. Those are that particular number and one only. For example, if you are going to take uh, number 5, number 5 has factors. Number 5 can be able to divisible without having any decimal point by 1 and the 5 itself, okay. So we are going to say that number 5 as uh, a prime number. We may have also a doubt that uh, why there is no one as prime number, because one can able to divisible by only one number, that is one itself only. We can divide one by one itself only, but the meaning of prime number is we have to have exactly two factors, but for one we are having only one factor, that is one itself only. So we cannot say that one as prime number, okay. Next, composite number. All counting numbers which are not prime are called composite number, okay. A composite number has more than two factors, okay. Composite number can able to have more than two factors. For example, 6, as previously discussed, we have it can be divisible by 1, 2, 3, yeah, and 6. So here having total four factors. Okay, it means more than two. So we can say that 6 is a composite number. Okay, next. So yeah, I haven't mentioned any examples, right? So you may I'm asking you a doubt. Is one is a composite number or not? Let you discuss and tell me. Let you guys discuss and tell me. So one is not a prime and not a composite also. It's neither prime nor composite because uh, what is the case of prime number? It should have two factors, exactly factors, not less than two, not more than two, right? But one having only one factor, that is one itself. Okay, when coming to composite number, the rule is it should have two more than two factors, not less than two, not equal to two. It's more than two factors, but one having only one factor, that is one itself only. So we can't say that one has a prime and one has a composite number. You should note all these points which I am discussing right now, which those are very useful to you guys. Okay, next we are going to discuss about a perfect number. A number, the sum of whose factors except the number itself, except the number itself is equal to the number is called a perfect number. Example 6, 28, 4, 96, etc. If you are going to, what is this meaning, sir? For example, if you are going to take 6, 6 factors are 1, 2, 3, 6. So if you accept the number itself, we are going to take 6, right? So neglect 6. 6 is also a factor of 6, right? In any number itself, factor to its own number, right? So we exclude 6. If you are going to perform addition between other factors, those are 1, 2, and 3, we will get the resultant as 6, right? Which is equal to the number 6, right? So we can say that particular number is a 6. For example, if you are going to take 28 also, you get the same, and 496 also, you get the same thing, okay? You just cross check it, okay? See, this is the thing which I have discussed. The factors of 6 are 1, 2, 3, and 6, and 1 plus 2 plus 3 is equal to 6. Why we haven't to included 6? Because we shouldn't include the 6 number because we are going to take the factors of 6 itself, right? So that's the condition for the perfect number, okay? That's the definition in it. Sorry, yeah. For example, 28 also, we are going to have 1, 2, 4, 7, 14, and 28. If you are going to exclude 28, those remaining numbers are 1, 2, 4, 7, and 14. If you are going to perform addition, we will get 28. Okay. Yeah. Proprimes or relative primes. Two numbers, listen carefully, two numbers, not prime numbers. Not prime numbers, two numbers whose HCF is one called Crow prime numbers. It's not the two prime numbers, it's the two numbers. See, the one thing is all the prime numbers, if we are going to take any two prime numbers, always the HCF is one itself only because all those are divisible by themselves and one only, right? So if you are going to take any two prime numbers, then those HCF will be one. But co-prime co-primes is not about the prime numbers. It's discussing about all the numbers, okay? Not only the prime numbers. So most of the people confuse with this topic, okay? So if you are going to take examples 2, 3, those are prime numbers, right? Those common factor will be one. Okay, common factor in the sense HCF, highest common factor, right? Yeah. For example, 8 and 9, if you are going to take 8 and 9 are composite numbers, not the prime numbers, right? Which means these co-primes are related to all the numbers, not only particular prime numbers. It's related to all the numbers. 8 and 9 are composite numbers. So if you are going to take the HCF of this 8 and 9, you will get the one. The topic HCF and the topic about HCF we are going to discuss in further classes. Okay, yeah. Next, various types of numbers in the twin numbers. Here, two prime numbers whose difference is 2 are called twin primes. Twin primes. For example, it's discussed about particularly about prime numbers only. Before co-primes are discussing about all overall all numbers, but here twin primes are discussing only particular to the prime numbers. Okay, two prime numbers whose difference is 2. Okay, for example, uh, what we are going to take 3 and 5. Okay, 5 minus 3 will be 2, right? So then we can able to say that uh, 5 and 3 are co-twin primes. Okay, so 5 and 3, 5 minus 3 will be 2, and 5 and 7, 7 minus 5 will also will be 2, 13 minus 11 will also be 2, are primes, pairs of two twin prime. These are the numbers which are twin primes. Okay, rational number, numbers which can be expressed in the form of p by q form. Okay, p by q form, p by q form. Okay, where p and q are integers, um, q not equal to 0. It means p and q are integers, which mean it means p can be negative, p can be positive, p can be 0. Okay, but q cannot be 0, but q can be positive and negative also. Okay, if q becomes 0, if what happens, the value will be become undefined or undefined. Some people say it as infinite, but it's undefined, we can't able to define that value. Okay, yeah. Some of the examples are 1 by 8 minus 8 by 11, 0, 6, 22 by 7. 22 by 7 is the approximate value of pi. Remember the thing. Approximate. It's not the exact value of pi. Pi. Pi is a irrational number. Okay. 22 by 7 is a approximate value of pi, so that we are going to take it as a rational number. Okay. Even if you are going to see it 0.6 bar. This number also a rational number. We can also express this number in the form of p by q. Okay, we can also express this number in the form of p by q. How? How in the sense means, if we are going to take 6 by 9. Okay, 9, 6. Okay, 0 times, right? 0 times 0 point, we'll get 6 here, right? uh, 9 6 are 54, right? 9 6, we are going to add 0, right? 54, again we will get 6, right? Again we will get 6. If we're going to continue, again we are going to add 0, and this will continue, right? So 0.6 bar is a rational number. It's not a irrational number, it's a rational number. Then what are irrational numbers? If you're going to ask me, next we are going to discuss about that only. Okay, numbers which when expressed in decimal, which when expressed in decimal would be non-terminating. Non-terminating means those are not ending, those are not able to end. In the sense, if you are going to take it 0.6, okay, 0.6 bar. Okay, see, 0.6 is terminating, which means it's ending after 6, there is no other value. Okay, it's get terminated. Okay, it means ended. That value is ended up to 6 only. Okay, after 6 we don't have any continuation. If you are going to take 0.6 bar, bar means the 6 is going to repeat like this up to infinity. We are going to place infinity number of 6 after 6. Okay, so it means it is non-terminating, but it's It is repeating. Repeating means in the sense the 6 itself repeating up to infinity, right? After 6. So it is non-terminating but repeating. Remember the point. Okay. If we are going to take 0.67, 8, and so on, and so on, and so on, we don't know what the value. Okay. After 9, we can't able to say that the next value is also a 9, because it is this number is continuously repeating, continuously ongoing. It means it is not non-terminating and also non-repeating, because it's not getting repeated for a particular value, because we haven't mentioned any 9 bar. Okay. So it is continuing up to infinity. After 9, we can't able to say that 9 can be repeated after till infinity. Okay. Infinite times the 9 will be repeated, we can't able to say that, right? So this number is particular number is non-terminating and non-repeating. Non-repeating in the sense any particular digit is not getting repeated, as we have seen in second case, which is zero point 0.6 bar. In second case, zero point 0.6 bar, the 6 bar means the number is non-terminating because it's not ending, right? 6 bar means 6 is getting uh, repeated till infinity. But it is repeating, right? It's not a non-repeating, it's repeating, because uh, 6 is getting repeated up to infinity. Okay. But when you are going to take the case 0.6789, which is I have discussed, and so on, and so on. In the sense, I have mentioned and so on because after 9 we can't able to say that 9 is getting repeated. If I mentioned 9 bar, then we can say able to 9 is getting repeated, then this number will be a rational number. But I haven't mentioned any bar. I am saying that after 9 it's going up to infinity, but it's not the 9. Okay. So many any value between 0 to 9. Okay. So it's neither terminating nor having any repeated digit at the end. Okay. So this particular number will be irrational number. So remember this point. This is the meaning of uh, this line. Number which expressed in decimal would be non-terminating. Non-terminating means it shouldn't have any ending. Okay. And non-repeating. Non-repeating means it shouldn't have any repeating value. In decimal, it shouldn't have any repeating single value repeating up to till infinity. Okay, as we have seen in the case 0.6 bar. Okay, you shouldn't have any case like that. Okay, so those numbers will be irrational number. Okay, example root 2 will be 1.141, root 3 is 1.732, and root 4 will be 2. Okay, root 4 value will be 2, and root 5, root 7, and yeah, let me. Okay, yeah, pi. Remember, pi is also a pi is e. E is which we are going to use in logarithmic natural logarithmic case, right? So pi is also a irrational number. Remember, whereas 22 by 7 is the approximate value of pi, so we are going to consider it as a rational number. Okay. So I have, as I discussed, see this number 0.2317647, it is continuing till infinity, but we can't, it is not repeating any particular value, right? So we can't able to say that 5 is being repeated till infinity because we haven't have any bar. Okay. Yeah. Yeah. Yeah, let us discuss what is this. Yeah. uh those are the, I think, completed, right? Okay. Those are the all about the types of numbers. Let us discuss about some important facts about the numbers. All natural numbers are whole numbers. How is this possible? Natural numbers are start from 1, 2, 3, and so on. Whereas whole numbers are start from 0, 1, 2, and 3, right? And so on. It also extending up to infinity. So if you are going to see 1, 2, 3, and so on infinity up to infinity, those numbers are also present in whole numbers, right? So that we can say that all natural numbers are whole numbers. Next, all whole numbers are not natural numbers. This is why, because 0, 1, 2, 3 are the whole numbers which are actually not present in natural numbers, because natural numbers are starting from 1 and extending up to infinity. But natural number doesn't contain 0, right? So we can't able to say that all whole numbers are not natural numbers. All whole numbers are natural numbers like that. So all whole numbers are not a natural numbers. Next. Zero is whole number which is not a natural number. So that the point I have discussed here. Okay. Yeah. Even plus even number equal to even number, as in the example 2 is even number, 4 is even number. When we are going to perform addition between 2 and 4, we are getting the resultant 6, which is also a even number. Okay. Yeah. Similarly, odd number plus odd number equal to even number. If for suppose 3 is a odd number, 1 is a odd number, and going to perform addition operation between two odd numbers, we are going to get 4, which is a even number, which is even. Okay. Yeah. Even plus odd number equal to odd number. Similarly, 2 is a even number, 3 is a odd number. When we are going to perform the addition operation between even and odd number, the resultant will be odd number, which is 5 in this example. Okay. Yeah. Even number minus even number is equal to even number. So in this case, 4 is a even number, 2 is the even number. When you're going to perform subtraction between two even numbers, will be even number, which is 2. Okay. Yeah. Odd minus odd is equal to even number. 7 is a odd number, 3 is a odd number. When we going to perform the subtraction between two odd number, the resultant will be even number. Okay. Yeah. Even number minus odd number equal to odd number. 4 minus 3 equal to 1, where 4 is a odd number, 3 is a odd number, and the resultant 1, which is the subtraction of 4 minus 3, is also a odd number. Okay. 4 is even number, I mistaken. Okay. Yeah. Next, odd number minus even number is equal to odd number. Okay. For example, we are going to take odd number, one particular odd number. I haven't added those examples, right? Odd number 7 minus 4 even, which is even, equal to 3, right? Which is odd number. Similarly, even into even number is equal to even. Even number 2 into 4 equal to. So I added examples because to reduce time. Okay. 8. Next, odd into odd number is equal to odd number. For example, 3 into 1 equal to 3. 3 is odd number, 1 is odd number, and resultant 3 will be all odd number. Next, even into odd is equal to even number. Even number 2 into odd number 3. Odd number 3 is resultant 6 is a even number. Okay. Yeah. The smallest prime number is 2. So if you are going to take prime numbers 2, 3, 5, and so on. Okay. Smallest number is 2 itself, right? So this is the fact. Smallest prime number is 2. Okay. The only even prime is 2. The only even prime is 2. So if you are going to take prime numbers 2, 3, 5, 7, and so on, 2 is the only even number. Remaining all the prime numbers are odd numbers, because any even number is completely able to divisible by 2, right? So it can't able to we can't able to say any other even number has a prime, because For the prime number condition is the factor should be one and itself only, the number itself only, but 2 will be a factor for all the even numbers. So we can't have other than two, any even number as a prime number. So the only even prime is 2. This is the point you should remember. Okay, so I hope you got the reason why. Okay, the first odd prime is 3. The prime number start from 2, 3, 5, 7, in which 2 is even. Then the next number will is 3, which is the first odd prime number. Okay, that is all about this point. Okay, next. 1 is a unique number, neither prime nor composite. This is already I have discussed with you guys, right? So because 1 is having only factor 1 itself, which is having only one factor. But for the case of prime, we should have exactly two factors. Those are 1 and itself only. So where in the case of 1, the factors are only 1, which is 1. Okay. So I can't say able to say it as a prime number. Whereas in case of composite number, we should have factors greater than greater than 2, right? So where in the case of 1, the 1 is having only one factor, so we can't able to say it also as composite number. So 1 is a unique number. It's not neither prime or composite. Yeah, the least composite number is 4. So if you are going to take composite numbers, these are the prime numbers, right? These are the prime numbers. I'm going to show it like that, right? Composite numbers. 1 is not a composite number, right? So exclude it. 2 is also is a prime number. 3 is prime number. So the next number is 4, which is a composite number. That is the this point is discussing about that. Okay. I hope you understood this point. Okay, next. The least odd composite number is 9. The least odd composite number is 9. If you are going to take uh, odd composite number, uh, 4 is the composite number, first composite number, as I have discussed. 5 is a prime number, and 6 is a composite number. 7 is a prime number. 8 is a composite number, and 9 is a composite number because it is divisible by 3. If you're going to take 8, 4 is a even number, 6 is a even number, and 8 is a even number. Next, 9 is a odd number, which is a composite number. So it is the least odd composite number. This point is discussing about that only. Okay, I hope you understood this point. 9 is a odd composite number, which is least odd composite number. Okay, yeah. This is all about this video. Actually, I thought it would be 20 or 30 minutes. So I hope you all guys this video is very useful for you guys. I'm new to YouTube. I need your support. If you like this video, please like it, share it, and subscribe to AK APT Logics. See you in the next video, which is all about this divisibility rules and some other formulas and all those. I'm following the S Chand AS Aggarwal. AS Aggarwal, I think so. Yeah, those publications and have done so many problems. I have an experience of 3 to 4 years on solving those examples. So, if you have any suggestions to give me, you can give me in the comment section. I will, I take those suggestions in a positive and change accordingly. And I also don't have in touch with this mouse pad. I am so that I can't able to write clearly. But I think my PPTs are very good to present, right? So I also share this PPT at the end after completing all the concepts, conceptual matter. I will share this PPT by combining topic wise. I will give to you, and I will discuss. I will not discuss all the problems, but I will discuss the problems which most of the people, most of the students felt difficulty. Those problems will be discussed. I don't want to waste you guys' time. by discussing all the problems. So I will discuss only the uh, most important questions. Okay, so this is all about um, me, and this is the first video to of our channel. I hope it will still continue till 100 video with your support without any description disturbances. It will give me a support to make more videos if you are going to support me, guys. Thank you, guys. Thanks a lot. Enjoy.